大家好，我叫Steven Turbin，中文名字是唐文礼。然后我今天非常期待能够向你们教这门课。我本来想用中文来教课啊，但是呢，你们这个课的这些 organizer 就跟我说，我讲中文的时候讲话有点太台湾腔了，有点太嗲了，所以呢，我就非常悲剧的决定还是用英文吧。So I'm going to use English for the rest of this. But if you want to talk in Chinese during our live sessions, 那就欢迎啊。I'm really excited about this class and about what you guys are going to learn over the next 4 weeks, 4 weekends, 3 weeks. A little background on me. So I'm a Harvard College graduate. I currently work at McKinsey, where I do work focused on data science in the US and in China. And I think that when I think about this class, I actually think back to what a mentor of mine at McKinsey mentions, that those who understand how data work are going to be the future of business. It is the people who can understand both how data works and also understand how business implications and business works, who will succeed in the long run. And I think a quick data point for this, I'm very focused on data, is the percentage of chief data officers in the Fortune 500. In 2012, 12% of Fortune 500 companies had chief data officers. Now in 2018, that number is around 70% and expected to go to 90% by the end of 2019. So that's to say that if you want a path to CEO that used to be going through finance, used to be being the chief financial officer, chief strategy officer, now more and more it's being the chief data officer, the chief marketing officer. So when you see that, you see, wow, businesses really believe in the power of data. And if you want to get a leg ahead, if you want to have a step ahead, you should focus on data yourself. And so that's why I'm excited about this class. I'm excited about bringing you guys along and helping you out in that journey, because it's not easy. And we're going to dive in deep. So I want to talk about the expectations for this class and for this session of videos. We're going to focus on two main things. The first thing is practicing problem-solving techniques that the best business leaders and business analysts understand. So how do you take a difficult problem, a business problem, break it down into small parts and begin to answer the question? And then how do you use that? Using data. That's what we're going to try to discover. And if you can do that well, you've gotten most of what you need to succeed in the business world. The second part is what I would call the most important part of data analysis, and that's exploratory data analysis, occasionally referred to as EDA, but exploratory data analysis. And what exploratory data analysis is the beginnings of a deep dive, an analysis of what am I seeing in the data, what matters, and what doesn't. And I like to say that exploratory data analysis is 80% of the job, because if you can do this well, if you can take out insights from the data initially, then you've pretty much finished everything you need to do. Then building the model, bringing it out to clients, showing your team what you've learned, that's all secondary. So if you can do EDA well, exploratory data analysis well, then you're 80% of the way there. So those are the two things we're going to talk about today. We're going to talk about problem-solving techniques related to business problems, 1. And 2, we're going to talk about best practices for exploratory data analysis. So let's dive into those two. We have some learning goals. So I don't want to spend too much time on this, but as you're going through the video and as you're thinking, as you're reflecting, as you're working, because it's going to be involved, it's going to be very dynamic between us, go back to this learning checklist and say, hey, am I learning everything I need to learn? Am I getting what I need to get out of? And if you, at the end of this, can say, check, I've understood every part of this, then that's what we need, and that's what we ultimately want you to end up with by the end of the course. So this is for you. Take some time now to look through it. Take some time at the end. We'll show it again and think about, did you learn everything? And if not, where do you need to spend more time? We have some homework for you guys. This is the most important part, is where you're practicing. There's a couple of stuff. We have a business worksheet for you guys to do. This is related to the problem that you will be solving for the next 2 weeks. You'll be getting some data fields for it. You're going to download this video game set, which you'll be using. You're going to be doing the 3 steps of data visualization. You're going to create 3 pages of PowerPoint presentation to present those out to your manager, for example. And you're going to need to work with a TA, work independently to download the data from Kaggle. Just a little bit of context for the case question. What are you going to be trying to be answering? Here's a case question, and it's your job to make this a smart case question. But imagine you're working for a consulting company that's helping a large video game distributor try to decide on a future video game setup, trying to predict what's the next big thing in video games. So the question is, what are the characteristics of a good video game? And how might this be different in the US and Japan? So those are the questions for you. Again, the goal is to find a successful video game. Success for them means high income, so it's earning a lot of money, a lot of revenue. So you guys will be looking at, there's a couple of variables. There's worldwide revenue, Japanese revenue, US revenue. You'll look into all of these. They provided you a data set to answer these questions, and they're interested, are there any differences in their Japan and US market, the 2 biggest markets for them? And they want specific recommendations. What type of video games should they make given the data? What are you going to suggest for them given the data used? So all the considerations, you can look at them. I think you guys have got it. But how are you going to approach this problem? How would you define the problem? And then what exploratory analysis are you going to do? This week, it's all about exploratory analyses. You're just going to take what we did today, put it into a PowerPoint presentation, and then we're going to look at it as a faculty, as a teaching staff. Fill out the sheet. This will be helpful for you, and we'd like to see how you think about it. There's going to be a lot of questions you won't be able to answer, but that's very normal. Also fill this out. What is the data that you want? What is the data that you need, etc. Okay. Let's talk about understanding the business context. And so how can you use data to address a business context? And let me give you guys an example from my life. So I'm going to work at McKinsey. McKinsey is a very and for good reason, incredibly private place when it comes to client information. So there's no time throughout this entire course, which I'll talk about specific company names, or sometimes I might even not talk about specific sectors, and that's just to protect the privacy of our clients. But I really care about this. I think it's important, so I want you guys to have examples of what real business questions are like. So let me give you one example. So a few years ago, I was working on for a large natural resources company, and they were trying to understand how could they use data to address questions within the company. So the CEOs, the C-suite came together, and they were trying to figure out, what can we do? They've heard a lot about artificial intelligence, AI, and machine learning, and they were trying to understand what they could do. They made a mistake early on, and the mistake that they made was that they went immediately to the data. So they went out, they hired a mathematician who had started an AI company, and they initially went in trying to figure out, what AI can we use? A year later, they called in a few other people to help them out, myself included, to try to figure out what went wrong. So what went wrong? And As you might guess, the problem was that they didn't solve a business problem. They were trying to use the best current methodologies, but they weren't diving into what exactly was the issue that the mining company needed in order to increase their value, to increase value to their customers. And that's the importance of understanding the business question. For example, if you are a large e-commerce company, the question might be, what should the products be that I offer? That's an analytical question. You can say, let's optimize the assortment and figure out what products we want to offer. If you're a retailer, you could say, what size of clothing should I have? If I'm in China versus I'm in the United States, that's very different. I grew up in the center of the United States. Let me assure you that the sizes are very different and quite a bit larger where I grew up. If you are a company that has hundreds of stores, where is the next best store to open? So you have to understand what is the business question first, but then what we're going to talk about right now is how do you solve an open-ended business question? It's one of the most difficult problems, and if everyone could do it, we wouldn't need people to come in and help out. So let's solve, how do you solve an open-ended question? Well, the first part of solving a question is understanding the context. So let's talk about an example that we'll be using just to ground this, to make this a little bit more clear for you and for me. Let's imagine you're working for a large e-commerce company. The company is subscription-based. So imagine that in order to access cheap products online, you need to have a subscription. So they have a discounted rate of products that might be at cost, very low cost. But in order to access them, you need to have a membership. So that's the type of model. Unfortunately, this company's grown significantly over the past few years, but they have what's called a large churn rate, 流失, so a large churn rate. And what this churn rate means, and the churn rate specifically, is that every month, some percentage, X percentage, say 20% of their customers are leaving, are no longer renewing their subscription. And the question that we have is, so your manager is the vice president of data, about to become chief data officer, like we mentioned, and they want to know, why are people churning, and what can we do to prevent it? So what I want you guys to do is to spend a few minutes, say 5 minutes, and I'm going to have you guys answer the 4 questions that we laid out. I just want you to spend some time writing about it, thinking about it, and we'll come back together to think about how you might answer those questions. Questions are, how would you approach solving this problem? What data will you need in order to solve the problem? What analyses would you do? And would you build a predictive model? And if so, what model? So these are questions that will, at the end of this course, be second nature for you to answer very fast. Now it might be hard. You might not even have used a predictive model before. Hopefully you have, but if you haven't, you might not know. So let's talk about, I'm going to give you guys 5 minutes to work on that, and then we'll come back together. And I'll discuss some of my thoughts and a framework for approaching it. 哎，我回来了！呜！我跟你们说一个秘密啊，因为我不是一整天都要拍这些视频啊，就是有时候因为比较忙嘛，就是要等到隔天才能拍，所以我就是很多人会这样子了，所以但他们会什么，就是不会换衣服之后会像我现在就穿的一模一样的衣服。但是呢，我有一个问题哦，就是我的头发真的太乱了，所以应该你们可以看出，就是今天的头发跟昨天的头发就不一样，所以我就希望大家就可以原谅我，就拜托了 ，please. Okay, so let's move on from my hair. And let's talk about this example case question. So I just gave it to you guys. Hope you spent a few minutes going through the case questions. If you haven't, pause this video, go to it right now, and spend 3 minutes just thinking about these questions. First question, and I'm going to talk about how I would think about this, and of course there are a number of answers, and I'm hoping that in our live broadcast when we're talking, that we can go over these questions a little bit more in depth and debate some of them. So the first question is, how would you approach solving this problem? So whenever we're thinking about starting off with a problem, we want to start with going back to the context. What do we already know? So we know this is a large e-commerce company. It's subscription based, meaning that you can only purchase if you have a subscription. They have a large churn rate, and they want to know why. So that's what we know right now. So I think a initial way to solve this question is to try to scope it down. So what exactly are we talking about? What exactly do we mean by churn? And what exactly do we mean by how would you predict? So in this case, we know what churn is. So churn means which customers will not renew in their next month. So we can take a data set from that. We can quickly go and say, okay, well, we understand we're looking at the next month. Let's look back in time for 5-6 months and then try to predict when the next month, let's say the 7th month, they wouldn't renew. How would you predict is a little bit more difficult and more interesting, because really there are two things going on here, and we're going to discuss this later on. One is prediction. And what prediction is you take in data and you predict an outcome. You say, I believe that given this data that I've used, given the algorithms I use, that we're going to have someone who's going to churn, someone who's not going to renew. So that's prediction. But when someone says prediction, they also might mean, why is someone not renewing? So in this case, it might mean, well, someone's not renewing because they had a really bad experience last time. Or maybe they didn't find the products they needed. Or maybe a friend bought them the subscription, but they never used it. So this is a little bit different. This is, why does someone not renew? So when I'm first approaching the question, I would really spend some time thinking about, what is it that we're actually trying to get out? Are we trying to do prediction? Are we trying to understand why? Are we trying to do both? And that's going to influence the next few questions. When it comes to data we'll need to solve the problem, this is where strategic thinking is very important. And we're going to talk about how you pick data in a few minutes, a couple of pages. How you pick data. Let me give you an example of how not to pick data. So a few years ago, I was working for a large commerce company, and one of the people who was part of the analytics team was trying to predict churn. And the way that they approached it, they said, well, let's get all of the data we can possibly get. Let's get everything we could imagine. So that means all the information about customer, all the information about the time and place, information about the products, information about the stores, etc. So they spent maybe 2 months, a month and a half, 2 months, 6 to 8 weeks, working on collecting this data. And when they went to the prediction, what they found out was that the single biggest indicator of whether someone churned or not was their satisfaction. Didn't have anything to do with the products, didn't have anything to do with the stores themselves, didn't have anything to do with even the time of the year. It just happened to do with their satisfaction. And if you had thought critically about what might lead to churn in this case for this commerce company, you might have come to satisfaction quite quickly. And instead of spending 6-8 weeks trying to collect all the data under the sun, you would have gotten to an answer much more quickly. So that's what we're going to talk about data collection, because it is one of the longest periods of being a data analyst, getting the right data, and it's probably the most critical part that you can do. So I'm really excited about that. What analysis would you do? Again, this relates to what the question is. Initially, and what we're going to do is I would explore the data before I go to any algorithms, any predictive methods, which are really exciting, they're fun, they're sexy, but they don't necessarily answer the question. I would start doing some quick visualizations of, what am I seeing? What does it look like? Do I see any quick trends in the data? And then I would probably move into a model like a linear regression, or if I needed prediction, maybe in a tree-based method, if I wanted predictive power, I might move something like a random forest XGBoost, which is a better predictor, but not as good at interpretation. And finally, would you build a predictive model? Why or why not? This is a question that you'll have to have a conversation with your manager about. Again, what is the goal? And I hope that's the biggest takeaway. Whenever you're trying to answer a question, try to figure out, what is it that we're actually trying to get out of here? If it is trying to predict it, then we do need a predictive model, and we should end up with that. Even though our exploratory analyses are very important, we need to end up with that model. If not, it might be enough to do some quick analyses, get some insights, and say, hey, we've done what we need, let's move on. Moving quickly is a very rare skill for people who work with data. And if you can do it, you'll distinguish yourself from others. So that is some of my thoughts. I want to talk about a 5-step approach to approaching a question for analytical professionals. And we're going to do deep dives into the first two. The first is defining the problem. So this is what we've been talking about in the previous slide. So what is it exactly that I'm trying to solve right now? What does it mean to be successful? What does it mean to find out an insight that is actionable? So you need to understand not only the problem, but also what is the context behind the problem. If you have a company that is trying to grow very quickly and try to acquire more customers, it's already growing quickly, that's a different question than a company that is, like in the case of this e-commerce company, that's experiencing a large churn rate and is trying to figure out what is going wrong. So understand the context, define the problem, be specific as you can. Second is figuring out the data. So what data do you have? What data is available? And what data is quick to get? If data is useful, it takes a long time. You may not want to get it for the first few weeks. You may want to use the data you currently have available to try to answer the question as quickly as possible. If not, you need to get more data. Decide what data you need. Third is creating an analytical approach. So many people jump to this step first. They say, okay, I've got a predictive task. Let's dive in. I know what I'm going to do. I'm going to use a random force. Use XGBoost. Unfortunately, if you haven't done A or B, it's very hard to do C well. So watch out. Very important step. We'll talk about this in week 2. How do you pick an analytical approach? But don't jump into this before you've done your homework. Finally, implement the analysis. Make sure that you're doing what you need to do, error-free, make sure it makes sense, gut check it. Then finally, and we'll spend a lot of time on this in the 3rd week, and especially coming to your final presentations, visualize and communicate your results. One of the rare skills of a data analyst is to speak convincingly about something. So can you describe what you're doing? Can you make it seem understandable, interesting, fun, impactful? And if you can do that, the final step, you're on your way to being Chief Data Officer. So these are the 5 steps. We're going to go through these 5 steps. We're going to deep dive into the first 2. And the first is defining the problem. So how do you define the problem? There's a 5-step framework that many companies use called the SMART framework. And this can be used in 2 different ways. One way is goal setting, which is very useful. I'm happy to talk about that during our live podcast. And another way, which we're going to talk about today, is defining problems. So how do you get a problem? That seems very broad. Let me give you an example. Imagine you are working for a fast food company, and they're trying to increase revenue. The CEO has come to you and says, hey, come to your team and says, hey, we really need to expand the amount of revenue we're taking in, the amount of money we're taking in. Could you help us out with that? So you say, yeah, I would love to help out with that. But what exactly does that even mean to help out? So let's talk about how you might break down that problem. I'm going to talk a little bit about some of the errors that I've made early on and some of the things that I think we all need to work on and some things I would focus on. First is specific. So define the customer group we are focusing on. So let's go back to the e-com example. Let's define the customer group that we're focusing on. Are we focusing on new customers? Are we focusing on people who have been customers for a long time, what we call value customers? Are we focusing on people who have taken a promo and used it to get membership but then left it? So we need to define the base, be very clear. In this case, you might say, hey, we're interested in churn broadly. So let's pick a group of customers which we consider normal. So you didn't get a membership from a promo, if we say that's rare, and let's say you have a tenure between more than 3 months. So you didn't immediately get it and get off. So we're talking about these longer term customers, and that's going to be the focus of analysis. So that's smart, specific. So measurable. In this case, we have a good definition for this. We define churn as not renewing your subscription the next month. So again, we need to be specific. Let's say we take the data from January through June. Then we're saying in July of this year, 2018, you did not renew your subscription. That's measurable. So make it as specific and measurable as possible. Action-oriented. So when we are talking about our problem, make sure that we are not only being specific and measurable, but how do we make sure that what our question is gives us results that we can actually act upon? In this case, we might reformulate the question to what we had previously was, how would you predict which customers will not renew their membership next month? Another question might be even better would be, what actionable factors lead to customers not renewing their membership in the following month? So that's actionable because you're looking for the factors, even if something's very predictive. Let's imagine someone's hair color is very predictive of someone not renewing. Unless we got a huge truckload of hair dye and tried to dye all of our customers' hair, it wouldn't be useful. That's probably not the case, but we need to find things which are useful, which you can actually use. That's probably a better way to formulate this question. So let's go back. Relevant. Relevant is an important step. In this case, you need to be only doing the analysis for what matters. We talked about the data example, collecting so much data that doesn't matter. When you're defining a problem, make sure the problem is relevant, and at the same time, you need to make sure that the data you're collecting is also relevant. And then time related. And this is probably the one that I have had the hardest time with, and I think that it's one hard for data scientists and data analysts. So time related. Can we set a very specific actionable timeline on this? So again, going back, how might we improve this question? Instead of saying, how would you predict which customers will not renew their membership next month? You might say, what are the actionable factors which lead a customer to not renewing their membership next month? Can you have these actionable insights in the next 2 weeks, for example? So creating a timeline for yourself. So that's the SMART framework, and of course the time-related area can be difficult. It was initially difficult for me as well. So I think that we're going to be practicing this framework, and you're going to be using this for later problems that you'll be using, and it is, I think, remarkably important to understand how do you structure a problem such that it's easy enough for you to attack. Many of the best business leaders are able to take difficult problems, broad problems, and make them small and concrete. So being a strong analyst is a bit more than just using the right analytical techniques. It's actually about answering the right question. So the pictures, I think, are a really good example. You have a friend come over, a neighbor come over, knocks on your door and says, hey, do you have a screwdriver? Screwdriver? You say, well, I don't have a screwdriver. Sorry, I can't help you. And they say, oh, okay, that's okay. They go back home. Now, imagine if the conversation went like this. Hey, do you have a screwdriver? And you say, no, I don't have a screwdriver, but what are you trying to do? Your neighbor might say, well, I'm trying to put up my picture. You say, oh, I don't have a screwdriver, but I do have nails and a hammer. Maybe I can help you put up the picture. You say, oh, that'd be great. That's exactly what I need. And the same happens all the time in analytics. So your manager is probably not that technical, probably doesn't know much of what you're doing and can't dive into the code. This is very common across firms that use analytics. So your manager might ask you, and I'll give you an example of something that happened to me. when I was doing churn analysis for a retailer, the question was, hey, could you predict churn? And could you predict it as well as you could, like the highest percentage accuracy possible? And so I went back and I started working on this, and I started trying different algorithms. I used the random forest, I started tuning. It was awesome. It was so good. And I brought it back to them, and they said, that's really interesting. Thanks, Stephen. But really, we want to know what we can do about churn. It doesn't really matter that you can predict it. We want to know what it is. So what I should have done before diving into the question was trying to figure out, well, what is the reason you're asking this question of me? Why does this matter? So we're going to be doing a lot of that work and practicing that, because if you can do that well, and when you're interviewing, this is very important. When someone asks you a question, often take time to figure out why are they asking the question, whether it's a case interview, whether it's a technical problem, and understanding the root cause will lead you to be more successful. So let's use a framework that's often used at consulting companies, which is one of these problem statement sheets. These are pretty general, so it's not specific to any specific company, but they're incredibly useful ways to define a question. So what I'm going to have you do is try to fill out this question with as much as you can about the e-commerce question we've been talking about, the churn rate question. So even if you don't think you have all the context, try to fill it in and maybe add in question marks. So if you don't know exactly why the e-com business is interested in churn, maybe make an assumption and say it's because they want to make more money off of these pre-existing customers. Maybe add a question mark next to that. So dive into this. What do you have? What don't you have? What defines success? And then what is the scope of the project? You might not have all the answers to this, and if you don't, that's great. Leave them as question marks. I'm going to give you guys 3 minutes to work on this, and then let's dive back together. So let's come back together in 3 minutes. So you should have spent some time working through this. There's no right answer for this. Some things that you should have figured out, and if you didn't put these down, I would go back and think about it. Your basic question is what we talked about, and that is, what are the actionable factors which lead to a customer churning? And we define churn as a customer that leaves the next month. The context is it's an e-commerce company. It seems they have a high churn rate. And the question is, can they do anything about it? I mean, part of the context, I think, here is understanding that they don't know why it's happening. And they're trying to find help from someone who understands data to figure that out. Constraints, you only have the data available at the company. You can't create new data. Success is what we talked about, is finding the factors which lead to success. And then the scope is that we're only looking at data for the 6-month period we talked about. You might have slightly different answers, but it's important for each project that you're on to try to fill out a sheet that's similar to this. Try to answer that question of, what exactly am I trying to solve here? Let's go into the data, though. And data is one of the biggest questions and problems. Like I gave you the example of someone who spent 2 months collecting data that they didn't need. That's not what you want to have happen. There's 2 ways to think about. There's 2 parts of the data we describe here. One is all the data that you want. So it's the data that you would love to have. It includes, and this is what the analysts did for this company. They found all the data they wanted. They wanted to have customer profiles. They wanted to have store profiles. They wanted to have time and day of purchase. It's all the data you want. And the second is all of the data that you have. And I think this is written as 现有的数据, right? But really it's 现在有还有现在方便的数据. So it's not only the data that you have, but it's also the data that's readily available, that's easy for you to get. And when you have those 2, that forms a center of what is the data that you currently are going to be able to use. And it's very important to figure out early on. A good strategy for this is to first to go, don't look at the data and say, what's all the data I want? Sometimes companies can come back and say, oh, we actually do have that data. But once you've done that, then go to the other side and say, well, what data is available? and what data is easily available. When you have those, the intersection will form the data that you'll be using. So here we have 所有想要的数据, right? So all of the data that you would like. That includes customer profile, last purchase info, which products are most purchased by customers that churn, social media data, a ton of broad amounts of data. And the data that you currently have is a question, and that's something we would figure out. You might not. You might have, you probably have purchase info, but you probably don't have social media info. You might not have their IDs, for example. You know, when you're thinking about this right half, the data that you currently have, it's available, it also is important to be creative. There's a project I worked on where we wanted to have profile data on the customer, but it was very difficult because all we had was the point of transaction data. We could only look at when someone purchased something. But how do we then get information on who these customers are? So what we found out is that every time you make a purchase, if you're part of a rewards program, you give your email. And if you use your email, then you can connect that to the profile of the person, and then you can have the details of them. So there are creative ways, but at the end of the day, you can only do analyses on the data that is relatively available. So I'm going to give you guys a little bit of practice. This will be another quick practice. And I want to pretend that you're trying to predict the average income of a given job. So this might be relevant to you guys. I know part of the course is about getting you guys skilled up, as you should be, in order to take great jobs in great companies. And that's what we're going to do, help you do. Now, part of the question might be, why are you guys interested in being data analysts and being data scientists? Obviously, it's the most interesting subject on earth and the most attractive teachers. No? Okay. But another reason might be that you think that being in data science is high paying. So we've devised a little bit of a project that we'll be doing during our lessons to try to predict what is the best paying job. And we're using a little bit of historical data to do it. So I'm going to give you guys 2 minutes to think about how to answer this question. So how can you predict a well-paid job, how well a job will be paid, and then what are the characteristics of a high-paying job? So spend 5, let's say 3 minutes just writing down things you might want. I already gave you a start. So number of years education, location, whether or not a job uses data. Think of 5 to 10 more. Now let's get back together. It's a good practice because when you're on the case, you need to think of what's all the data out there. Really good data scientists think of that. Employees, many people just wait to be told that by their manager, but you should be the one thinking about it. So I'll give you 5 minutes, or give you 3 minutes to think about that, and then come back. So give yourself 3 minutes. Great. So you hopefully came up with 5 to 10 different data points. This is good practice. You're going to need this for the job that you're going to be doing. And it's important here to be creative. So be creative as you can when you're thinking about it. So some things that you might have thought of are, we talked about location. It might be industry of job, whether or not it's a nonprofit. Is it for the government? You might have thought of even a little bit more out there, for example. One that we'll be exploring is how prestigious the job. Is it really cool? Do people want to be in the job? Another might be, which who knows, how active people are who work at the job. So what is the profile of the people who work at the job? Are they active on social media? Are they fit? Are they good looking? So things that you might not think that are predictive could be predictive. I mean, for example, height of the average employee actually is predictive of how much money they make. That's something you might not think about, but is it a data point that's actually quite predictive of income? So think more broadly. So let's step back and say what we've learned so far. So we've talked about two main things. First is, how do you define the problem? How do you understand what it is that you're trying to solve? And hopefully I've given you guys a little bit of a structure to do that. I think the worksheet that we practice is a very useful way. What is happening? What is the context? What are the constraints? What's the scope? All very important. Of course, the question is, are you answering the question they want to ask? So that's one. The second is, what is the data that's available to help us answer that question? And how do you think about what data you can or cannot use? And I think the pushes there, again, were twofold. One, be creative, think broadly about data. What can you get? But then two, be realistic about how quickly you can get data. So data that you can get quickly is better than data you can get more slowly, all things equal. So those are the things that we stop. So now let's imagine you have the data, and let's dive in to what I believe to be the most important part of a data science path, and that is exploratory data analysis. I've said it before, I'll say it again. If you do exploratory data analysis well, you've done 80% of the work. So what is exploratory data analysis? It's not the most sexy. You won't be called the coolest kid for doing this, but it is the most important. So for all the people that don't think it's sexy, they're missing out on a huge value, and you're going to capture that value, and you're going to do better than them because you know this. So at a high level, exploratory data analysis is the very first thing you do with data once you have it. It's looking at the data and trying to understand and make a sense of what's happening, trying to communicate to yourself, what am I seeing? What trends are there? What data is weird? What data is surprising to me but seems to be strong? So what is happening? You look at patterns, you look at trends, you look at exceptions, and what it does, it provides a day one answer. So at many managing consulting firms, there's this idea of a day one answer, and this is what happens. So in many team rooms, for example, you'll arrive first day, you'll have 3-4 hours, you'll get the data, and someone will already be working on making a PowerPoint deck, for example, that will have the entire storyline of, let's say you're working for 3 months, for the 3 months, and your manager will come to you and say, hey, so I've given you a couple hours, so what do you think is happening? And you might be like, what? It's been like 3 hours. How am I supposed to what? Like, that's absurd. But it happens, right? Because from their perspective, they need to have answers quickly. And they need to understand what is happening. They want to have something to come to their managers about, the VPs, the CEOs, whatever it might be. So in order to get that answer, you're not going to be using algorithms. You're not going to be doing anything fancy. What you need to do is quickly visualize, summarize, and understand the data and allow them, and then take that insights and communicate it well. And if you can do that, you've done most of the work because you've said, hey, I'm already ahead of this. I understand what's happening. And when you want to get an answer solved, you can solve me. So at McKinsey and in many places, this is really one of the more important skills. So let's talk about the steps of exploratory data analysis. And there are 3. The first is a simple summary group of statistics. So what's happening? What are the averages? What's the distribution? How far apart is something? So we're going to talk in a bit about predicting salaries for a job. So hopefully very relevant to you. How do you get a good job? You better predict it. We're all making predictions all the time. And the first thing to do is to look at the variables that you have available. So what is the average salary of a job? What does it mean to be good? What does it mean to be bad? I mean, if you're making 100,000 USD, is that a lot? I think it's probably a lot, but someone else might not. So those are the things you have to define. So first, getting the means, seeing how wide distribution is, the highs, the lows. And this gives you an overview of the data. It shows you what fields you currently have. What is the data I currently have available? Finally, it says, helps you understand what exactly is happening here. So that's summary. Second part is probably the most important in this part, so I would focus your efforts on this, and this is visualization. So you're developing a number of graphs that allow you to understand what's happening in the data. And this is important because this helps you do two things. First, it helps you understand the trends. So are things going up over time? Are most incomes in one group, or is it distributed one way or the other? Are there some people who make a ton of money, some people who make no money? Or are there any weird points? Maybe there's a few careers where people are making way too much money. It doesn't make sense. Let's say I gave you a data point where I said the garbage collector was making $4 million USD a year. You'd be like, what? That doesn't seem right. That seems wrong. So visualizing lets you see trends, lets you see what's happening, and then allows you to see, which is detect outliers and deep dive into data points. So now that you have a high level view, you've seen some of the summary statistics, you've understood the trends from visualizations, then you dive in deep into the outliers and into specific data points. So what exactly is happening there? Why is this data point the way it is? I mean, there are many studies I've been on in which 75% of what I do is just exploratory data analysis. It is just bringing up graphs which are solve business problems. A very small example, for example, is we're trying to understand how people make choices between products. This is not the example, but imagine you go to a supermarket and you're trying to decide. You're a supermarket, you're trying to predict, say, what types of yogurts I should have. One way to do that is to look at multiple yogurts at once and see which yogurts people buy at the same time. This is called co-purchasing. So co-purchasing is a very interesting concept. It means you bought, let's say, strawberry and blueberry yogurt, say, at the same time. Very popular in the U.S. And that helps us understand, well, if you bought strawberry and yogurt, strawberry and blueberry, maybe if you don't have strawberry, you'll still buy blueberry. So they're substitutable in some way. The most important analysis that I did for that was just looking at what is called a waterfall analysis. And it was just an exploratory data analysis which said what percentage of people only buy one type of yogurt, how many people buy multiple types of yogurt, and how many people buy multiples but of the same type. It's a very simple analysis. It doesn't take any real analytical background, but it was incredibly powerful. And that was the slide that the CEO saw, for example. So incredible power in exploratory data analysis, and that's why I want to spend a little bit of time on it. So summary statistics are great, but they have a problem. So here I've given you 4 sets of data, and if you did the math, you would find that they had the exact same mean and variance on each of these. So mean is the measure of centrality, variance is how much it spreads, and you would say, okay, well, these are exactly the same. So summary statistics are useful. You would say, okay, so these are all exactly the same. I did my summary statistics. But if you don't visualize, you won't realize that these are actually very different. And so this is an example of 4 data sets which all look identical through summary statistics, but are actually quite different. If you plot each of them, you see, well, these 4 lines all look completely different. Set A looks like it's a linear line. Set B looks like there's a curvilinear relationship, so it's moving like that. Set C seems to have an outlier, right? So that's not the same. And then set D is very weird, as one point was out. But if you just looked at the mean and the variance for X and Y, they would all look exactly the same, even though, as we can see, they're clearly they're not. So you need to spend time doing visualizations. And I'm going to go over 2 quick visualizations, which we'll spend a little bit of time with, which are incredibly important. The first is the histogram. So the histogram is a way of measuring a single variable, showing the center, showing its distribution. It shows outliers if something's very weird on one side or the other. This is one of the most common graphs you will do, what graphs you will see, graphs you should use. And we'll show some ways to make beautiful histograms in R. Of course, they might be misleading. They're not perfect. Some of the issues with histograms is that if you have one outlier, then it skews all the data. It's really hard to make sense of it. If you don't have very much data at all, you may not get an understanding of the distribution. But I love histograms because I studied statistics at Harvard, and this is all probability theory. So if you see a histogram, what you're really seeing is a distribution of the variable, which might follow a number of different variables, like a normal distribution or something called the Poisson distribution, Poisson. So you understand how a variable is. Very useful. Of course, it's not the only thing that you'll be using. The second and very important one is a 2D scatter plot. And this allows you to display a relationship between two variables, x and y. What this does is it allows you to spot relationships. And if you go back, this is a scatter plot. We went from x and y data, and then we made it into a scatter plot. And you can see, oh, okay, so in set A, it's a straight line with some variance. Set B, it looks like it's a curved line. Set D is just weird. What's up with set D? I don't like set D. That's what we might decide. So this 2D scatter plot is one of the most useful. And obviously this is this is not rocket science. But if you don't do this well, then and you don't do this thoroughly, then you're going to miss out on a lot of relationships. Some limitations here, of course, they exist. It's sensitive to scale, and outliers can make visualizations quite difficult. And if you have three variables that you're interested in, they're interrelationship between the three, you can't do this in the two-dimensional. But just to see how two dimensions work, this is very helpful. And you can also make a few callouts. So you're looking at this data set, and you look at the bottom, and you say, oh, I see a couple of points which look a little bit weird. What's weird about them? And then in step C, you can do some deep dives. Of course, scatter plots can also help you see when there's no type of relationship. So this is an example where we would scatter plot and say, okay, looks like x and y don't relate to one another, at least directly. They might relate to each other through another variable. In this case, this would be a linear relationship. So again, we're seeing a straight line. We'll talk about linear regression come next week. Here you might have a quadratic relationship. So again, this is where you might have a curve going up. Again, you wouldn't be able to get this from just looking at summary statistics, and you wouldn't be able to do it without plotting the graph. And here's the warning. Let's say you use a linear method to try to solve this, try to predict this, and you never looked at the graph, you would get bad results, and you wouldn't know why. So without a doubt, you need to spend time doing these visualizations. So what's an outlier? And then I want us to dive together into an example using a data set. So an outlier is an observation that deviates so much from the normal that you might think it's generated by a different mechanism. So this is really important to understand. People talk about outliers all the time as being strange, weird. You might say that someone who is an incredibly talented pianist someone who plays piano is an outlier. But there are actually two definitions at play here. One is an outlier in the common sense of the term. That's how people use it in English. And it just means that someone who is extraordinary, very talented, very good looking. No? Okay, never mind. Very smart, whatever it might be. When we're interested in outliers, we're interested in data points which actually are different from the rest of the data. Not because they're extreme, but because they might come from a different process. So let's say I have housing prices, and every house is about $1 million, and then I have one house which is $1 billion. It's 1,000 times more. That's an outlier. And that's probably not an outlier because the house is actually at the $1 billion and it's a great house. Probably an outlier because someone accidentally put another zero when they typed it in. So outliers are data which come from a different mechanism. Something happened there. It might be poor data quality, it might be the wrong value, or it might be exceptional data. In the case of exceptional data, you'll probably keep it. If something's exceptional, keep it. If something makes sense, keep it. It's only if you believe data is not right that you want to get rid of. So those are the 3 steps that we talked about: summarizing, visualizing, and then deep diving on outliers. And if you do all 3 of these well, you've done 80% of the work. So that's exploratory data analysis, and I want to do a deep dive example with you guys using R and using the Prestige data set, which I'll be using for the next week. So let's watch and do a little bit of data analysis together. And I'm going to do this on the Prestige dataset. So the Prestige dataset is a dataset from the 1970s in Canada, which gives characteristics of professions or careers and the average income. So it's related to our question: how do you predict whether or not someone will have a high-paying job, or how high-paying of a job it will be? So that's the question we're going to solve today. We're going to do it in R, which is the recommended programming language for this course. You could also use Python to explore this. This is actually a small data set, so you could even do it in Excel if you wanted to, but I would recommend using R and following along here. I'm going to go through this. We're going to go through the 3 steps together just to show you how I would approach it. I'm using R Markdown, which has some nice visualization. So let's dive in. This is going to be very in the weeds, so feel free to skip ahead or skip back, but I think it's good to show you guys what I'm actually working on. So here we go. I have these packages in R, which I'm going to load. ggplot is a great library for some graphs. Okay, and now we have the Prestige data set. Head gives me the first 5 rows. So let's look at this. So I have got government administrators. They've been education means something. I don't know what this means yet. I'm trying to figure out what this is. So early on, you're trying to understand what are even these data variables mean. Income, I think this is probably in dollars, Canadian dollars. Women, I'm not sure. I think this might be percentage of women. I'm not sure. Prestige, I believe this is how prestigious it is. So my guess is higher is better, but I'm not sure. Census, I don't know. It's a census number. This is type. I'm not exactly sure what that means. So I have some questions, and I have some things I'm trying to figure out. So let's do a little bit of this. So education, I think it's years of education, and this is very common that you might not know exactly what the data is. So let's go. So questions to ask yourself early on: what are my assumptions about the data? So is this actually years? Is this actually Canadian dollars? Is this US dollars? What might I already believe to be true? So these are the variables that we have, the 6 variables that we have. So my guess is education is related to income. So the higher education, the more income you have. My guess is also that prestige is related to income. Those are my guesses. And what else would I like to know right now? I'd like to understand what the heck prestige means. What does it mean to be prestigious? So let's look at that. So let's do this. This is another way of looking at the first 2 rows. Yep, here we go. We've got education here, income. Yeah, I'm thinking this is years of education. This is probably percentage of women. So let's keep going. And then this is a great function. So I'm still not sure what the column census means. It's just this weird number. Census refers to a survey that's given to all of the different people within the country. So I'm not sure what it means. Let's do what a very common function in R, very useful, called summary. It's going to give me the min, max, and mean. So this is minimum 6 years of education, maximum 15. Here we go. We're getting some initial insights. It looks like the largest salary is about $25,000 a year. It makes sense because it's in the 1970s. Women, so it goes up into about 100. So again, that's probably about a percentage of women. So here we go. 30% is the average. And the median is 13%. That means that most professions don't have women, and because the mean is higher than median, some professions have a lot of women. So maybe that's a teacher, maybe that's a nurse. We'll figure that out. And then prestige is similar. Median, mean are related or close to each other, so it's probably somewhat normally distributed. I still don't know what census means. Type, prof is maybe professional. So I've already got some initial insights. I know that income has some outliers. Women, most jobs are mainly men at this point, and then there's a distribution of prestige. I already know a lot about the data set. I can already say some interesting things. So what do the different types mean? I don't know. What is census? I don't know. And what was this data taken from? So, and then finding some questions. What is this profession with 97.5% women? And what is the profession with the max income? So that is the question that I'm interested in. So let's look at the documentation. This is going to help us out. Solving this question, checking out some LinkedIn, looking at the best places to work. I don't have Wi-Fi access. Oh, this is embarrassing. Let's connect. And let's go back here. So we're going to move on from the documentation to the visualization. We've already gotten some interesting insights from this. Namely, one of the big insights is that there are more men than women, and that there's a distribution of incomes. Okay, let's look at this. We now have internet access, live in the dream. Now that I have internet, 好开心的，真的超开心的。So this is the data set prestige. It's from 1971. And this is helping us understand. Prestige is some score, so it's from 0 to 100. Oh, so census is just a code, so we can ignore that. This is like equivalent of me looking at a data dictionary. So this is a great way to do it. You start off, before you look at the data dictionary, just look at the data. Try to understand it. If you don't understand it, fine, go to the data dictionary. Type is typok. This is good. It's a factor, meaning there's groups. So as opposed to it being numerical, it's groups. BC is blue collar, probably mean less high income. Prof is professional, and then WC is white collar. Okay, great. This is helpful. So let's spend a little time visualizing these variables, and let's see what insights we get from that. So qplot is from ggplot, which is one of the best packages in R for visualizing, and it's going to give us a quick visualization right now. So the red line is the mean, the median is the income. So now we're looking at the histogram, which we talked about, of income. So it looks like somewhat normally distributed, and this is interesting. There's some values which are some groups which have very high income, so that's useful. Let's come back to that later. I'm going to do the same thing for education. Okay, education pretty normal, some high educated, some low educated, but pretty centered around here. And let's look at prestige. Oh, no, let's look at the census variable. I'm going to use hist, which is very similar to histogram, but it's a little bit of a faster function for doing this. It seems kind of random, and this confirms our belief that census is probably not a useful variable. Something weird is with census, it probably just is a census number or an ID number, so we probably don't need to deal with it. So yeah, it doesn't have much meaning. Let's look at some other variables. Let's look at prestige. Yeah, prestige is interesting. So prestige is distributed. So you have some really very prestigious things. Some things are not prestigious at all. And most things are like meh. Most things are kind of fine. So that's interesting, and this is good. So when you have a normally distributed variable, oftentimes it means that there's enough variance in it that you can use it for predictions. So it's possible that prestige might relate to income. I think it probably is, but let's confirm that in a bit. And finally, let's look at women. Oh, this plot's really interesting. Yeah, okay. So this is really fascinating. So this is not prestige anymore. This is actually women. Average women. Okay, let's do this again. So women. So we have some professions which are very women heavy, and some professions which are, most professions in the 70s are dominated by men. So that's an interesting point. Yeah, it's very interesting. So this will actually is an interesting question of how we understand the data and what's happening percentage of women's like we thought, because it is right distributed, the mean is higher than the median. So that makes sense. Yeah, seems like it's bimodal, having two peaks. So we've already taken a ton of insights from the data. So some from one variable, we already know that census doesn't matter. Let's get rid of it. Some professions are very male and some are very female, but there are more male than female professions. And then 3, income is right-tailed. So some people make a ton of money, like you guys will. Let's go data. And most earn a normal amount. So let's look at the relationship between variables. And this will go to we talk about scatter plots, the relationship between. Before we start that, it's important to start with some hypotheses. So what do you think is going to happen? So I have 2 hypotheses. The first is that education is positively related to income. So the more you're educated, the more money you're going to make. That's my first prediction. Second is that the more prestigious your job is, the more income you're going to make. So let's look at those 2. So let's look at hypothesis 1, relationship between income and education. And this blue line is a linear regression line, which we'll discuss later. So it looks like, yes, we are seeing a positive relationship between income and education. All this code, by the way, will be available to you, so you can use it and play with it and use it for your own baseline. So we have, interesting here, we have these 2 little outliers where you're making a ton of money. So I want to know about those outliers because I want to make a ton of money. Let's talk about that. Yeah, an important question is this relationship straight? So does this look like this is the right line, or maybe it should be curving? So as you get more education, you make even more money. So we have to think about that. Is the straight line assumption true here? So this is a similar view, but it's using a different model, a generalized linear model, to make the prediction. And again, we're seeing a little bit more of a curvature here. This actually seems still somewhat straight, but then we're seeing a curve up right here. So that's useful. And actually, what you might even be seeing here is that if you have not graduated from high school, that there's not much of a education difference between going to 8th grade or going to 11th grade. So that's interesting. So a curvilinear relationship. So we have 2 main insights right now. Always at the end of whenever we're doing these analysis, think, what are the takeaways? For me, there are 2. 1, education and income are positively related. And 2, it's probably not linear related. It's probably curvilinear related. Because let's look at prestige as well. Prestige. So again, yeah, similar relationship. This actually looks a little bit more linear. And this is with income and prestige. So this is a little bit more. So my insights from that are, 1, prestige is correlated with income, and that 2, there appear to be 2 outliers. Again, probably the same outlier, and they are the same outliers that we should look into. So finally, we're going to look at the correlation matrix. And so this looks at how related the variables are. This is very useful. I would do it for your analyses later. I'm going to visualize this. Points. So 1 is most correlated. -1 is completely negatively related. 0 means no relationship. So I'm going to visualize this. And yeah, so just quickly what we're looking at here. Of course, the variable women is related with itself perfectly. That makes sense. But here's some interesting things that we're learning right now. So it looks like income and prestige and income and education are positively related, so around 0.5. But women and income are negatively related. So the more women in a profession, the less money you make. So this is really useful. And frankly, at this point, we've almost solved the problem. Right? We've done most analysis. So we already say, okay, income is related with education positively, prestige positively, and women negatively. So you could almost stop here and say, well, maybe my insights are that I should look for a job with no women, which is very sad. And this is not true, probably not true as true today. I hope not, because it's from the 70s. But if you're in the 70s, you say, I want a profession with a lot of men, very prestigious, and I have to study a lot to get there. So that's probably what you would say. Okay, so now let's do some point analyses. And point analyses are important because they let you deep dive into points and say, why am I getting these weird results? What's actually happening here? And is there something potentially wrong with my data? So view is a good function. It allows you to view the data set itself. Here we go. Okay, so looking, it allows you just to deep dive. These data sets like lawyers, making a ton of money, not many women, but actually not a lot of women who are lawyers. Primary school teachers, not making much money, but a lot of women. Yeah, interesting. So we're already seeing this out. Nurses, a lot of education, mostly women, not making that much money. So this is, yeah, you're learning a lot right here about what is happening. Radio, TV announcers, mostly men, making decent money. Yeah, fascinating. Okay, so this has allowed us to do a little look at the view. So well, the question that we often ask outliers are, should we be removing any of the data points? And the only reason we would remove something if it's a data error, a low quality measurement, or a manual error. And let's go back to prestige, and we're interested in those two values. We're making a ton of money. So what are those two? Not babysitters. They're general managers and physicians. So general managers, you're some adult team, right? Whatever. You're not that educated, but you're making a ton of money. So does that seem right? Kind of question you have to ask yourself. Does that seem right? Maybe they're business people. So physicians or doctors, a lot of education, making a lot of money. That makes sense to me. So let's again look at the general managers. These are all functions you should look at afterwards. Take some time, talk to the TA about them. General managers are, it makes sense, so I wouldn't remove these because to my common sense, it makes sense that people who are business people or who are physicians make a lot of money. Income not found. That's fine. EDA. So let's step back. We just went through all the exploratory data analysis, and again, we're probably 80% of the way there. We've learned some really important things. So 1, education is positively related to income. That makes sense. That's useful. 2, prestige is positively related to income. Also makes sense. And 3, interesting, at this point in history, the percent of women in the workforce is negatively related to income. And it would be interesting to dive into that a little bit deeper. So what's actually happening there? Is it because of education? So are women less educated, so they're making less? Is it because of discrimination? And maybe that relates to prestige? What is actually happening here? We're not entirely done, of course, and that's why we're going to dive into more advanced analytical techniques to solve this problem, because these factors might be related to one another in ways we don't know. So it might be that the higher educated a profession is, the more prestigious it is. So the effect of prestige is just an education effect. It's not a prestige effect. So that's what we're going to explore today. But I want to give you guys an example. You're going to do exploratory data analysis just like this. And remember, big things, do the analysis, but always think, what is the insight? What is the takeaway? Is this actionable? Is it specific? What can I learn from what I'm looking at? we've just gone through some of the R, which we're going to be using, and I want us to go back to these learning points. Quickly go through them for yourself, and I would spend 30 seconds or 15 seconds on each just thinking, do I understand this? And if not, go back to the video, think about it, and bring some questions, have some questions down. But these are the main things we want you to have learned through this session. We have some homework for you guys. This is the most important part, is where you're practicing. There's a couple of stuff. We have a business worksheet for you guys to do. This is related to the problem that you will be solving for the next 2 weeks. You'll be getting some data fields for it. You're going to download this video game set, which we'll be using. You're going to be doing the 3 steps of data visualization. You're going to create 3 pages of PowerPoint presentation to present those out to your manager, for example. And you're going to need to work with a TA, work independently to download the data from Kaggle. Just a little bit of context for the case question. What are you going to be trying to be answering? Here's a case question, and it's your job to make this a smart case question. But imagine you're working for a consulting company that's helping a large video game distributor try to decide on a future video game setup, trying to predict what's the next big thing in video games. So the question is, what are the characteristics of a good video game? And how might this be different in the US and Japan? So those are the questions for you. Again, the goal is to find a successful video game. Success for them means high income, so it's earning a lot of money, a lot of revenue. So you guys will be looking at, there's a couple of variables. There's worldwide revenue, Japanese revenue, US revenue. You'll look into all of these. They provided you a data set to answer these questions, and they're interested, are there any differences in their Japan and US market, the 2 biggest markets for them? And they want specific recommendations. What type of video games should they make given the data? What are you going to suggest for them given the data used? So all the considerations, you can look at them. I think you guys have got it. But how are you going to approach this problem? How would you define the problem? And then what exploratory analysis are you going to do? This week, it's all about exploratory analyses. You're just going to take what we did today, put it into a PowerPoint presentation, and then we're going to look at it as a faculty, as a teaching staff. Fill out the sheet. This will be helpful for you, and we'd like to see how you think about it. There's going to be a lot of questions you won't be able to answer, but that's very normal. Also fill this out. What is the data that you want? What is the data that you need, etc. And then finally, there's going to be a little bit of extra readings, and the TA will send those out specifically to you, but these are them. We want you to understand, how do you approach problem solving, how do you approach exploratory data analysis, and how do you approach exploratory data analysis in R. So these are readings for you. They're mandatory, do them. You're going to get a lot from them, but they're a good addition to the practice that you're going to take. So that's it for this week. I'm really excited for us to be talking in person. Gerbil. I am looking forward to it. It's going to be a lot of fun. So save your questions to when we're going to be talking in person. But I look forward to chatting. Talk to you guys later.